Right. So we have a question here about the bolt misfit problem. The setup of the problem is we have a bolt and it's mounted within a sleeve, and then we put a nut on the end of the bolt and we're tightening it until there's no gap here between the sleeve and the nut. And the question ultimately the problem wants you to find what is the force in the bolt when you turn the nut a quarter of a turn from the condition where there's no stress in either of them and no separation between the sleeve and the nut. Turn it a quarter of a turn, what's the force in the bolt? But then we had a question from a student which was, how much does the length of the bolt actually change when I turn the nut by a quarter of a turn? So let's look at that. First, let's begin with a definition. We'll define the pitch of a thread as the distance between two adjacent crests of the thread. And that's going to help us with finding out what the change in length of the bolt is. So if that's the distance between the two crests, it means that for a full turn of the nut, a 360-degree rotation, we have a change in length of the bolt of P, P being the pitch of the bolt. So the change in length of the bolt equals P. And so let's look at the problem. We were told that this bolt has 5 threads per centimeter. 5 threads per centimeter. So what is the pitch? Well, if the pitch is the distance between two adjacent crests of our thread, two adjacent threads, then we know that the pitch must be equal to 1/5 of a centimeter. And so this is how much the length of the bolt changes for a full rotation. But we're told that we have a quarter rotation, so 90 degrees. And we want to know how much does the bolt move then. It simply moves by 1/4 of the pitch, and so by 1/20 of a centimeter. So there we have it. So using the concept of a pitch, we're able to find what the change in length of the bolt is with a quarter rotation of the nut. But remember, in this problem, it's not really the change in length of the bolt that we're interested in when we're finding the stress, but what we want to know is the total elongation of the bolt. And so in general, remember that the change in length of the bolt does not equal the elongation of the bolt, because we know that the sleeve has a Young's modulus of its own, and when we tighten the nut, the sleeve is going to be compressed by some amount. So the sleeve deforms as well as the bolt. So remember that when you're doing the problem, but at least we know now what the change in length of the bolt is.